Hello everyone. All right, so 15 more minutes to go till the start of the eclipse here in Nottingham. The eclipse will start at about 10, 6 minutes and 45 seconds. So all is good. The weather is a little bit cloudy, so there are some high altitude clouds on the sky, and the sun is covered, but we are getting an image of the sun, so we are going to see the eclipse. Okay, so what is interesting about this eclipse? Well, let's start with the location. So this eclipse is visible in this area that you can see here. So the maximum that you can get is if you are somewhere in Kazakhstan and in the Ural Mountains in Russia. The farther away you get from there, the less you will see of the eclipse. And I am currently here. So for me, I will only get about 16% coverage of the sun. And the eclipse will last about an hour and 43 minutes, starting at 6 past 10. The maximum, so the point where the coverage will get to 16%, will be at about 3 minutes to 11, and it will end at 10 to 12. So this is pretty much what we can expect today. So we have a few more minutes till the eclipse starts. 12 minutes. We can discuss a bit about eclipses in general. So as you can see, the eclipse is not visible throughout the Earth. This is different to a lunar eclipse. A lunar eclipse is visible for all people that see the moon during the eclipse. However, for a solar eclipse, because basically the moon is much smaller and it only shadows a little bit of Earth, we can only see a small area eclipsed. And there are eclipse hunters out there which hunt eclipses. It's really interesting to go out and see the eclipse as it unravels. Eclipses have been known since antiquity, and even before we assume, because they are a highly spectacular event. I mean, the sun goes black and basically everything changes. I've been around for the 1999 eclipse on August 11, and it was an amazing sight at the totality of the eclipse. There was a breeze, everything darkened, a cold breeze. The animals, the birds stopped chirping, and it was really something to experience that, and it kind of gives you an idea of what might have been in the heads of people in ancient times when they didn't know what was going on, and they imagined all sorts of dragons and creatures eating away the sun, and they would perform sacrifices to basically to help the sun recover. The earliest evidence of an eclipse that we can date for sure, and we know its location, is um, about 1200 BCE, so about 3,200 years ago in Middle East. And that helps us because eclipses help us determine the rotation speed of the Earth, which is not constant. Um, and that's pretty much as far as we can go back in time. Um, Obviously, we have written sources about older eclipses. In China, for instance, there were the case of the astronomers that were decapitated by the emperor because they failed to predict an eclipse, because eclipses were highly linked to the political intricacies of the regime. And that was 3rd century BCE, so 4,000 and something years ago. But we have eclipses and they repeat periodically every 18 years and 10 or 11 or 12 days they repeat. So the same eclipse occurs again, but offset by 120 degrees in the longitude. So for instance, in 18 years, this eclipse that is here over Central Asia will have the maximum somewhere, perhaps, if I were to guess, somewhere over the North American continent. So this mean of predicting eclipses called Saros cycle enabled past people to predict eclipses to a certain degree of confidence. But they didn't only use that, they used other things. They used the lunar nodes, which move across the ecliptic, which is the path of the sun. So the lunar nodes are the intersection point of the lunar orbit with the sun's orbit. And when those lunar nodes coincide with the position of the sun, then we have an eclipse. And because the lunar orbit is tilted and the lunar nodes move around the ecliptic, we don't get an eclipse each month. It would be actually really cool to have an eclipse every month, but we don't. So they are spectacular events in that sense, which have caught the attention of people. And the Aztecs, for instance, imagined dragons and celestial beasts eating away the sun. They would sacrifice. They would sacrifice, bring an offering to the gods to please and to help the sun god recover from the eclipse. And of course, it always did because it's a natural event. They didn't know that, so they believed that the sacrifices were helping, but in reality, they didn't. So a little bit over 6 minutes till the start of the eclipse, and I will move and share the uh, change position here and share the image through the telescope just before the start of the eclipse so that we can experience it. There are some nice features of the sun, but as I said, unfortunately, you can see this is, I needed to use a lot of gain from the device and increase the exposure time to actually get to see the sun. But it is really interesting. Today, you can see these prominences here. This really nice one, which was present on Saturday, which was the last time I saw the sun. And there are some nice prominences here as well. You can see a couple here and here as well. The north, this is about the probably the south pole of the sun. The north pole is here somewhere. The sun rotates like this in this image that I'm taking. And you can see that in one of my previous recordings, which are on YouTube. So I needed to stretch a lot the gain and the exposure time. This is an H alpha filter that I'm using. So basically it's not natural light. It's H alpha, so it's just a narrow band of the sun's surface, allowing me to see these prominences here, which normally you only see during total eclipses. That's when you see the big flares, the large prominences at the edge of the disk. Let's see. There's some clouds coming. Hopefully, we'll still be able to see the surface and to see the eclipse even at this high gain and with, let's say, a not so clear image because of the clouds. Yeah, we have a saying in astronomy that when there is a major celestial event, usually you have bad weather. So today is not that bad, but it's not ideal either. So let me give you a hint. I'm going to use SharpCap for the live stream, and I will. You can see here that there we go. This is the nice sun that we are getting. Let me try to decrease the gain a little bit and maybe the exposure time, and here it is. You see the nice surface of the sun. There are some faculae here and some filaments here, which are prominences, but you view them against the sun. And look here, you can see some nice prominences as well. So this is the sun that we are getting. At the moment, there are some high disturbances. Let's try to fix a little bit this one. All right, look, here we go. That's better. So increase the gain a little bit. Value around 37, 40 works nice. Okay, and not too much exposure. All right, just about that. So a nice image of the sun. You see here the prominences. I always confuse these two terms, use them interchangeably because they actually are the same thing, but depends on how you view them. If you view them against the solar disk, they're filaments. If you view them at the edge, like this one, look at this one. This is really nice. Let me take a snapshot of this one. This is really nice, and here as well, and this one here, quite active. It's putting up a show this morning. So just a little bit till the eclipse. To synchronize time, because I want to get as accurate as possible, I'm using dimension 4, which enables me to synchronize the time. So, all right. Let's see. So as you can see, the celestial dragon has started eating away from the sun in this live stream that we are getting. It's a beautiful image. Look at all the uh, clouds coming over. You can see the sun is eaten away by this beast right now. A large chunk of the sun is not visible anymore. So we are in the eclipse right now. Really amazing. We are 2 minutes in the eclipse, and look, the sun is going away. It's not a mirage. It is the sun that's eaten away by this celestial beast, which is the moon in our case. You can see some nice faculae and some filaments as well. This is amazing. The sun in H alpha. Look, you see the prominences. Look here, really extraordinary. This is amazing. Had no idea it is so cool. Uh, it's amazing to see these prominences together with the uh, moon over the sun's surface. All right, we're getting some intense sunshine here because the sun is out of the clouds. Nice prominences. Beautiful. You might even get some birds flying over the sun's disk. I usually do get these, especially in the morning. There is a huge uh, flock of birds here that it keeps flying in the morning. It usually goes over the sun. So if you get that, it would be even more amazing. So it's time for some incantations to bring the sun back because it's eaten away. And if you're trying to look at the sun right now, you'll see you cannot look at it. It's too shiny, it's too bright. You won't be able to see the eclipse with the naked eye, but you can clearly see it in this image. Once the recording is over, I will take some snapshots of this. These are really cool. Look, a cloud over the sun's surface now. Just a dim one. Right. This is amazing. Right, let's take some nice snapshots as well. And let's try to get some with the filaments as well here. If I push this to the limit, I might get some, yeah, look, nice filaments. Prominences. As I said, I always interchange these two. They are the same thing anyway. Ooh, some disturbances out there. It doesn't want me to capture the image. See, it eats away more and more of the sun as we progress into the eclipse. Yeah, some clouds. Really amazing. This is something. All right, so the clouds are gone. So we have the just playing here at different levels of gain and exposure time, just trying to capture some of those prominences in the image as well. Let's start a new recording. I'm going to stack these and see what I can get out of a stacked image. So usually if you want to get more details and clarity, you would stack several frames together. There are several software out there, AutoStackert or Registacks. They all do their job pretty well. Right, now it's nice and clear of clouds. You can see the surface and all the details. Now imagine that this is what you see here in Nottingham, but if you are in closer to the maximum, you'll see it eaten away in a greater chunk, and it will be visible with the naked eye. I mean, it's for instance somewhere in Eastern Europe, Central Eastern Europe, you get about half of the sun disappearing. Here you only get 16%, so that's not much. We have clear skies, and there are some. It's not actually clear. You should see a better image of the surface of the sun. But the reason is that there are some high clouds out there, which there we go. This is much better. You can see some filaments, faculae, the white areas or plages, prominences on the disk. It's eaten away quite a big chunk right now. This wouldn't have been visible by ancient people from this latitude in this longitude, so from this position, because it's simply too it's not enough. It's not covered enough for it to make a difference with the naked eye. This is amazing. You can see here a nice prominence. And there are some more here as well. The plages, the filaments, the faculae, these are active regions. mostly associated with sunspots. You don't see sunspots normally in H alpha, but you do see the other features which you don't see in um, with natural color filters like Mylar. I remember the first time I looked at the sun, I used a Wilding glass. It was one of those greenish Wilding glasses, which gave a green tint of the sun. And I tried to capture that through a webcam. It was 20 years ago. Still have the images somewhere. I might post them at some point. Really interesting. Look at this. It looks amazing. Look at the geometrical shape. It's like a Pac-Man. It's a celestial Pac-Man. The details on the surface of the sun are quite good. Look at the filaments. They're so sharp. It's really nice. I hope you're seeing these as well. Hopefully the audio is not making any issues. If it is, just turn it off and enjoy the image. We are only 14 minutes into the eclipse and it's already that beautiful. Let's take some snapshots as well. And let's try to play a bit with the gain and exposure. This is much better, is it? Taking some snapshots here. You can see the eclipse and you can see the prominences, and then look at these filaments here. I like these filaments. They look like small worms, like they crawl on the surface of the sun. There were a few comets, Kreutz comet fragments discovered in the, I believe, in the 19th century by German astronomer Kreutz. He studied them, and these are fragments from a big comet which constantly hit the sun. Nothing major, I mean, it just vaporizes before ever reaching the surface. But it is interesting to view them, and there were a couple of them. One was this last Saturday, and the other one was Saturday before that. This is a nice here. I'm not sure what this is. It could be a sunspot here, this area. It's not the dust on my sensors, fortunately. My sensor has some dust on it, which tends to ruin the taking some snapshots. Now let's take one of the South Pole region. Yeah, the ASI 120 MC sensor, 6 millimeters in diagonal, it is just about right to fit the entire sun's surface, but not entirely. I mean, if the edges, the extremities, if you can call extremities, it's a disk, are not visible when you're trying to fit it in the image. See, so, but it does allow you to get some very cool images here. Let's push it a bit, not too much. Yeah, this is more like it. Look at the size of that missing piece of the sun. That is actually our moon. Well, in a few million years, we won't get that nice image of totality of the sun, because the moon will be farther away from Earth. That's nice. 20 minutes into the eclipse, a really nice image of the sun. This is fantastic. These are Kodak moments. Look at those prominences here. I like this one. It's like a triangle here trying to get away from the surface. These all start from the chromosphere. The chromosphere is the region just over the surface of the sun. It's not that hot. During a total eclipse, you actually see the corona of the star, which, well, that's the hottest region, and it's somehow still a mystery why that's so hot compared to the surface of the sun, which is only a few tens of well, a few thousand of degrees, but the corona is way hotter. It gets up to million of degrees. They use these eclipses to demonstrate the theory of relativity. Back in the 1920s. More and more of the sun is eaten away by this celestial beast. This is the moon going fast around the Earth, and also the Earth rotating. So basically, the duration of the eclipse is given not only by the moon's speed, orbital velocity, but also by the Earth's rotation. So the Earth rotates, the moon moves around the Earth, the Earth also moves around the sun. So all these combined determine how long an eclipse will take. Look at these prominences. This is really interesting. It's amazing. It looks alive. It's a huge ball of plasma. The closest sun, the closest star to us. And we are just a speckle of dust. The size of planet Earth is like, let's say, this spot here. This probably a sunspot. This is how big we are compared to the gigantic size of the sun. some clouds. You notice the drop in luminosity, in brightness. Yeah. So this is the this is what we have so far. So let's continue our discussion on the sun and take some moments to um, relax, because it's will take a lot more. All right. So hello again, and we are expecting the maximum of the eclipse at about 10:57 and 48 seconds. So in a little under half an hour, we are going to stream the eclipse again. Now, as I was telling initially, these eclipses have been noticed around, and there are cases of um, well, people that argue that Neolithic people, so the Stone Age, did um, look at these eclipses and recorded them somehow. And I will show you in a second a really interesting example of a potential eclipse in the Neolithic. Unfortunately, there is no way of dating it because, as I told you at the beginning, the big problem with eclipses is that you don't know how fast the Earth was spinning at that time. The farther you go back in time, the greater the uncertainty. So because the rotation of the Earth uh, changes if a volcano erupts, if there is too much polar ice caps, um, if there's too much snow, for instance, in the northern hemisphere during winter, it all affects the rotation speed of the Earth. So it's really hard to say where was this eclipse visible. We know there was an eclipse because we know the Saros cycle. Each eclipse repeats itself every 18 years and in 10 to 12 days, but we don't know exactly where it was visible because we don't know how fast the Earth was spinning. So I will show you in a second uh, some some examples of this eclipse. So just bear with me, and you'll see a very old example of a possible representation of an eclipse. Hope you had some time to relax. And just before the maximum of the eclipse, I will share with you a nice image of what we believe is a representation of an eclipse. So here it is. This is a reconstruction of a very old Neolithic sanctuary in Romania. It is the Parța Neolithic sanctuary reconstructed in the museum in Timișoara, the west part of Romania. And what archaeologists found 40 years ago was this interesting window, circular window with crescent moon, and this here, a holder for ceremonial, let's say grains or whatever else they wanted to have there. Now, they interpret this as being the moon and this as being the sun, so the window being the sun and the crescent being the moon. However, as you've and we've noticed during this eclipse, it is the moon that eats away from the sun, not the other way around. So my interpretation is that it's the other way around. This is the moon here, the circular window, and this is in fact the sun, what remains from the sun during an eclipse. And you've seen it nicely, and I will show it again. There it is. So we have the moon that eats away from the sun. So in fact, it may be a solar eclipse that they recorded here. And this is the moon, and this is the sun. So very interesting. This is very old. This is about 7,000 years old. So it's remarkable, and we have lots of astronomical alignments and symbolism in that sanctuary. So it's really interesting to have such an example. Not many people know about it. It hasn't been been talked about outside of Romania that much. This is from one of my articles that I've written about the sanctuary itself. So yeah, I believe we have a very nice, let's say, complement here. We have the old Neolithic representation of a solar eclipse, and then we have the modern one with the camera and the solar scope. All right, so we are approaching the maximum, and I will again turn to the solar scope and try to stream the eclipse maximum. Okay, so we are back, and look at this. We had some clouds, and look at this big chunk eaten by the moon. So let me try to work a bit the that's really nice. Look at this. Now we have a full-fledged Pac-Man. We are going to record again this. Have some nice prominences near the South Pole, and we can see some nice active regions right now, and the moon near the maximum phase of the eclipse. Yeah. I'm gonna leave it like this. You can see the sun moving. This is actually the Earth rotating around its axis. It appears to us that as the sun is moving. You can see some nice features of the surface. Clouds. Huge chunk of the sun has been eaten away. There are some disturbances, but also the tripod shaking a little bit. So you need a sturdy tripod to enable a smooth image. Almost at the maximum. Almost at the maximum. It's The maximum will be at about 10:57 and 48 seconds. Five more minutes till the maximum. See here the prominences at high gain clearly visible, and also some nice ones here just at the edge of the solar disk. Oh, quite some disturbances and trepidations, but it is an amazing view. Just taking some snapshots, and let's see if we can adjust this a little bit and see if we can get some more details. Let's push the luminosity. We are 1 minute away from the maximum. So recording the maximum here, some clouds. 1 minute till the maximum, and then the celestial beast will retreat, will be defeated, and will run away from eating the sun. We should have maximum in about 30 seconds. About 15 seconds. And this is it. This is the maximum we'll get from this location on Earth for this eclipse. Now the moon will start moving away from this, from shadowing the sun, and the eclipse will end in about an hour. The Pac-Man is really beautiful at this moment. You can see the features on the surface of the sun. They're really something to look for. It's a little bit bright. Let's try to reduce the luminosity. Yeah. See some features in the center of the disk. Again, you have some nice prominences here and here, and some filaments and some whitish regions, which are the faculae or the plages. Sun is a bit bright, so let's turn down the gain. Some nice prominences here. This is amazing. I love these prominences here. One of them seems detached from the surface, the other one looks like a triangle, and then you have this faculae here, which are really nice, and some sunspots. We actually see a couple, one here and one here, probably sunspots, I'm not sure exactly. They could be filaments. Wouldn't have thought would look that beautiful. That's a nice cloud coming over the surface, like ghosts, alien entities. Yeah, so we just passed maximum 4 minutes ago, and it will end in about 48 minutes. So still have some time. So these eclipses, when they occur, they usually come in pairs. So let me try to bring this and have a look at the eclipses around this date. All eclipses, and let's have a look. All right, you see, there is a lunar eclipse just a few weeks from now. The reason is that in 2 weeks' time, the moon will be in the opposite node. So the moon's orbit intersects the sun's orbit in two places. They're called lunar nodes. Now it's near one of the lunar nodes. It's in one of the lunar nodes, and the sun is also there. When this happens, you have an eclipse, when both sun and the moon are near the lunar nodes. Now, since the moon has two nodes, in 2 weeks' time, it will be on the other at the other node, and in 2 weeks' time, we will have full moon. And because the sun will be in this node, in which it is right now, the moon will be in the other one on the opposite side. We'll have a lunar eclipse. So this eclipse will not be visible from this, will be visible from the Pacific, from the East Asia and North America, and also a little bit of Australia I see here, and South America. So these eclipses usually come in pairs. Usually there can be 2 eclipses or even 3 eclipses. The next eclipse will be in on 20 April 2023. It's going to be a solar eclipse, a total one, and it will be visible from Australia, Indonesia, that area of the world. And that too will be accompanied 2 weeks later by a lunar eclipse, as you can see. So this is what usually happens. They come in pairs. It can also happen that we have 2 solar eclipses and 1 lunar eclipse as well. It all depends on the configuration of the Sun, Moon, Earth system. The next one that will be visible from Europe, well, we aren't that lucky. There is one on 29th March 2025 that is gonna be visible again partially from Central and Northern Europe. And maybe this one on 8 April 2024, but let's double check. It barely touches. Oh, it's only going to be visible from a little bit from Ireland and Scotland and Northern Ireland as well. And that's pretty much it. So the best way is to be somewhere in Western Ireland, where you'll have about half of the sun covered. So that's in 2 years' time. But we will have some interesting lunar eclipses till then. So we'll have one next year in May and next year in October. Well, the first one is penumbral. It's not going to be that easily visible. It's not going to be that, the moon won't have that reddish tint, but the one in October will be partial. It's going to be better. Taking a break for a few minutes, and then we'll meet again in about 10 minutes to see the final stages of the eclipse, the end of this partial solar eclipse of 25th October 2022. All right, let's resume. So we've got clouds. The sun is completely covered. You can see it now, just a little bit visible. There isn't much to see. This is much better. We almost lost it there for a second. Again, clear skies. Now the Pac-Man is horizontal as it appears on my camera. Let's try to replay a bit and reduce some of these values here to see some of the details better. Okay, this looks better. You can still see the prominences here and here. Nice ones. Let's try to increase the gain a bit to see them better. Decrease the exposure time. That's not. Right. You can now see very clear the prominences, but it's not a pretty image unless you want to see the prominences. So let's try and bring it back. And it's in the clouds again. You can probably see it better if we push the gain to some extreme values. Even if it's in the clouds. So you can still see it. Once it's out, it's going to be completely white, just like it is now. So let's decrease the gain. Taking some snapshots here. And there are some clouds coming in. Barely grazed the sun today, the moon, from this area. Wondering what that fuzzy area, what causes that? I'll go check the instrument. Yeah, still lots of clouds that are affecting our view of the eclipse, but still an impressive sight. And it's gone. Yeah, just at full gain, barely visible. It's inside a cloud. Quite a long eclipse. Lunar eclipses take longer because the penumbra of the lunar eclipse also impacts the experience. Solar eclipses tend to be shorter, also because of the size of the moon. In the lunar eclipse, Earth makes a big shadow cone, and that increases the duration of the eclipse. Yeah, nothing visible so far. Cloudy weather. Fortunately, we were lucky. Uh, People I know from other places in Europe experienced bad weather, and their plans of seeing this eclipse were ruined. So we were lucky. Also, I may say, due to the British weather, which is comes and goes. Um, you have clouds, but they move really fast. So this means that you get a better chance of viewing, of actually seeing something, even if it's a little bit cloudy. If there is a nasty cloud there just hovering over the sun with no wind to push it away, then that's not good. So we have some really nice shots here. We witnessed the beginning of the eclipse, which was quite impressive, actually seeing how the moon eats away from the sun. That was really fast, actually. It happened really fast. Then we saw all these beautiful images. We saw all these beautiful images of filaments, of faculae, of prominences, and some possible sunspots as well. So it was really a good eclipse. Uh, Quite an experience to actually see it through the H-alpha scope. Usually you observe these eclipses through natural light. You just put some Mylar filter, for instance, in front of the scope and you view it, and that's it. Nothing else. So in this case, it was something. Let's try to push the gain a bit. Still nothing. There is sunlight, but the sun seems to be covered. Ah, there it is. Overexposed, high gain. Looks amazing. Probably too much gain. Let's bring it down a bit. Yeah, you can see the clouds. But at high gain, you can see some really interesting features. Can you see the nice prominence here, just this edge? Taking some pictures. Oh, the tripod went all crazy. I've accidentally hit it. Yeah, too much. Let's bring it down. It's almost over. In about 10 minutes maybe, it's gonna be over. Let's adjust a bit the exposure time. A bit too shiny around the center. More like that. Unfortunately, all those clouds moving over causing different intensities of the light kind of impact the experience. Not a good thing to use auto settings. You could use, you click auto here. It doesn't react well in real time, especially not for when things change really quickly, such as when we have clouds over the sun. All right, almost over. And this is going to be our last eclipse till 2024. That will be visible from this area. Clouds. Probably going to rain later on, but yeah. Oh, what disturbances we have here. It's causing the image to shake like crazy. And it's gone. Let's bring it up to full gain. Yeah. You can actually see I'm an hour ahead here than our for some reason. Not sure why, because it takes the hour automatically from the system. Maybe it uses the winter time already. All right, Let's decrease it a bit. Doesn't help much. Yeah, lots of clouds. Doesn't really help. And probably capture a few minutes of this just to get to the end of the eclipse. Oh, look at it play. It's shaking a lot. And it's almost over, almost over. You can barely see here the moon in this area. Barely see it. Let's bring it back into focus and barely see it. Just a little bit here in this area. And it's gone. I believe we can safely say that the eclipse has ended. That's it, with a lot of trepidation and shaking from my image of the sun. The eclipse has ended. It's about 10 to 12. All right. Thank you for those dropping by to see it. And you can always watch the recording again. It was an interesting experience, definitely for me to get a more sturdy tripod. And I hope you enjoyed it. Thank you and see you next time. Stay tuned, like, subscribe, go on Patreon if you want, follow me on Facebook, and see you next time.